me see. Okay, it's recording. Now, what I am saying here, first of all, you have to carefully look at the base case. So base case, n, x, you can see the check marks. Okay, no problem. But if you look at the question, this part is not going to match with this x. This x. This is a cross, okay? This is not x. This x. That's the problem. So you have to have, okay, I will put a check mark here so that I can see the compatibility, right? So this, those are the features that we are looking at so that we can write this, no problem. This is the base case. Now here, when it comes to here, you have this check mark, you have this check mark over here, but you don't have a check mark here. Why? Because this is not going to meet the criteria. Everybody understand what I'm saying, guys?
Yep.
Yep.
Right. Any question, please let me know. Okay, I'm going very slow. Why this is very important, like your life and my life. When I was learning this, I was like carefully doing it 18 years ago. Now you can't do anything. You can't do anything. You are stuck, right? You can do always you can do the expansion, okay? I'm not talking about the expansion thing, okay? There is no other way that you can do it because of this incompatibility. Now we are stuck, right? Now we are stuck. Now anything we can do here? Anything we can do here? Now we have to use a trick. Tricks are very important, okay? Tricks are very important. So this is the shortest way of teaching this, okay? You will see when you learn this in school or in other tuition, in other people when they teach this, okay? So they will teach this to you using composite functions, which is very hard to find. What is a composite function? Composite function is a function inside a function, right? Right? Function inside a function. So we will do those more. They are going to do this using composite functions, right? So what will happen? Students don't know what is composite function, and also students don't know what is differentiation. They don't know how to relate those. That is what is going to happen with most of the students that I have seen in my life. But here, I'm going to show you the shortest method and most logical method you can ever do this. Okay, so even in my PhD, I did this. If I get a differentiation, I use these tricks to do it. Everybody knows it, okay? Just not me. Everybody knows in the business, they know. But some of the teachers, they don't know this, some of the tricks, I don't know why. Okay, so they stick with their older, that longer method. Now, anything that you can do so that you can have 3 check marks. Because if you have 3 check marks, so then you can do it, right? Here, you have 3 check marks, you can do it. Now, how do you see? How do you check that? Now, I need some comments from Krish. Krish, anything that you can see? Anything you can think of here?
Not at the moment.
Okay, Krish, can you see this structure, right? What is the structure here? X, 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 right?
Yeah.
In other words, if I give you this, you will understand better. Okay. Mr. MJ. Okay.
Yeah.
If we have MJ here, MJ should be there, MJ should be here. So that means tick mark here,
Yeah.
Tick mark here, check mark here, check mark here. Everyone is okay now, compatible, right?
Mm-hmm.
Now, looking at that picture and looking at this picture, can you comment anything?
So that.
Okay. It's a little hard to think for the first time, but I'll show you. Please go through it very clearly. Now, what is the problem here? What is the problem here? The problem here is this, right? Here, you will have Michael Jackson. This is MJ, say for example, this is MJ, but this is not MJ, right? Clear?
Yeah.
This is not MJ. Because if you have MJ here and if you have MJ here, your game is over, right? See, if you have MJ here and MJ here, your game is over, right? If MJ is not there, we will create MJ. Look, we have 2x plus 1 to the power 3. This is MJ, okay? Please look at this. This is MJ. We will create MJ here. We will create MJ here. This is MJ. Can you see? Is it compatible now? MJ, MJ, see? D, MJ, MJ. You can see this. MJ, MJ. Can you see that? Guys,
Yep.
everybody, can you see?
Yeah.
Yeah. So who constructed this? I constructed it, right? That means this is the extra part I put there, right? Originally we had dx, right? Originally we had dx. I constructed it. That means I removed it and I put a different thing there to see the compatibility. Now this is my construction, right? The extra term I put here, right? What I will do, if I did something extra, I have to cancel it. See, I'm going to cancel MJ. You see that?
Yeah.
This part is going to cancel with this. So then essentially it seems I didn't do anything, right? Then underneath this, I will put dx. Clear?
Yeah.
So this is the construction I did. So this is seemingly cancelling each other, see? So then this is what here, this is what over here. Okay. So now equal, I will rewrite it. So I'm going to remove that. This is what I have, multiply by 2x plus 1 divided by dx. I hope everybody got it. This is the construction. This is the construction. Who helped me to do the construction? MJ. Because the pure observation, right here, this helped me. I saw MJ to the power 3 here, MJ, but that MJ is not here. So I constructed it accordingly. Clear what I'm saying? Guys, clear?
Yeah.
Yeah.
So now think about this part. I'm going very slow, guys, okay, because this is very important. I'm going to get this part. What is that? What is the answer to that? Think about it.
You said 2x plus 1 squared.
Say it
Yeah.
again.
I think
2x plus 1 squared.
2x plus 1 squared.
Uh,
oh
Wrong. Look at this analogy. If you have MJ here, if they are matching each other, see, these two are matching, right? Like
Yeah.
MJ and MJ, see, matching, right?
oh,
So then
Also,
what would be the answer? Answer would be 3 times
3.
mj to the power 3.
Yeah, yeah.
So the
Okay.
answer would be 3
3
times mj. What is mj?
2x plus 1 and then
Ah,
square. Okay.
x square. See the convenience now. See mj, mj, mj. I took that mj, right, so that I can clearly show this to you when I am here. You see the structure. It's all math is all about structures, guys. Okay, try to see that. Math is going to be so simple. Guarantee it. Okay. Any question here? Do you understand? This is nothing but that mj,
Yeah.
mj, mj. So mj is replaced by 2x plus 1, right?
Yeah.
So this is 2x plus 1, 2x plus 1. So 2x plus 1. mj is replaced by 2x plus 1. Easy. Sharin, everyone. Ravindu, all good? Could we?
Yeah.
Huh?
Okay.
Everyone is good?
Yeah.
Okay. Aditi, Bhavya, good?
Yes, sir.
Okay. Shannon, Sharin, all good, right? Please ask if you have any question. Now,
Yeah.
now that part is fine. Let's think about this part now. What about this part?
Is that just 2?
Huh? Now here again, what base case is involved here?
You have to use
Base case number 1, right?
no,
Why not?
because it has plus 1, so you can't.
No, this is base case number 1, right? Like this is, I'm saying related with.
Oh, okay, yeah.
I mean, this looks like base case number 1. That's the word, right? This looks like base case number 1. Suppose there is an actual elephant and a a wax elephant in a museum. I'm saying that wax elephant looks like the actual elephant. I'm not saying that is equal. Similarly, here I'm saying this is related with, looks like the base case number 1 because of this power, right? But essentially, we will use our basic understanding. This is called basic common sense. You can see this is power 1. Easily you can split it, right? You can say this one ddx of 2x because of this plus. You can do this, right? Easily here. You don't have to worry about these kind of constructions. You can just do this. This is very easy, right? Then the answer to this one is what? 2. This goes to 0, right? So the answer to the whole thing would be 2 here. 2 is coming here from here. 2 times 3 is 6. 6, 2x plus 1 to the power 2. That's the answer. You got it?
Yeah.
Guys, okay? You got it?
Yeah.
Good. Now this example I'm going to give to you. Please do it. Example 2. ddx of, I will give you the same thing, 2x plus 1 to the power 10. Now do that. I will show this to you. Quickly. Please do that quickly. Now, you can see, first thing you can think of, related with base case number 1, right? Base case number 1. Now, if you see x here, but you can't see x here, right? So you can see something else. So this is Michael Jackson. Michael Jackson is not here, right? So Michael Jackson is the whole thing, okay? 2x plus 1 is the Michael Jackson, right? So this is Michael Jackson with his jacket. Jacket is X. Now here it's just the jacket, no Michael Jackson. So now you can't do it essentially. This base case is very important, guys. You have to see the structure of the base case. So now what I will do, I will construct it so that I can use the base case. Right? So understand it. So I'm going to construct it so that I can have Michael Jackson on top. See, I have that. My MJ, I have that. Now, this is the construction, right? So this is the extra term I introduced. So what I will do, I will cancel it. And then I will put the original dx in the denominator. Now what you can see? Now you can see mj to the power 10. So that's why I put mj. Otherwise, you can see the structure. mj to the power 10. So if that happen, if you have that, the answer would be 10 times mj to the power 9. So mj would be 2x plus 1. See? Multiplied with 2x plus 1 dx would be 2. See? It's going to be 20 2x plus 1 to the power 9. Easy. How many steps? Just 1, 2 steps. I did it in my mind. But if you expand it, see what will happen. If you expand it, okay, you are not going to do it, right? Like you are not going to do it today. Probably take another day. Now, third question, okay, very good. I hope you understood it now. Now, if I give you ddx 3x squared plus 2x plus 1 to the power 6, please do that. Okay, so now here again this is related with base case number 1, but unfortunately you have x here, you have something else here. Again Michael Jackson here, but you don't have Michael Jackson here, right? So what you will do, doesn't matter what you have here. You might have a humongous thing here. Don't worry, doesn't matter, right? You construct it, whatever you have, you construct it here. 3x squared plus 2x plus 1, 3x squared plus 2x plus 1 to the power 6, and then you cancel it. So then when you do that, see, D Michael Jackson. So this is humongous, see. If you don't know the basics, so then you are going to stuck. That Michael Jackson helps you. D Michael Jackson to the power 6. If that happens, the answer should be 6 Michael Jackson to the power 5. Please understand that. So if you know those tricks, see, it's one shot. Please, sort of go through it. And this one, how to do this? This is plus, right? So you can just split it. You can split it. See, ddx of 3x squared plus ddx of 2x plus ddx of 1, right? So this is nothing but, you understand, this is directly the first base case. You can take 3 out, then ddx of x squared, directly first base case, right? Nothing to do, nothing to worry. So it's going to be 6x. Here, when you take 2 out, it's just ddx of x is 1. So it's going to be 2. So this is going to be 0 anyways. See, this is what you have. Then you have 6, 3x squared plus 2x plus 1 to the power 5, right? So I did all of these in my head, right? And then I saw that still I didn't touch any pen. I saw that 2 is a common factor here. So I took that 2 out and multiplied with 6, it's going to be 12. That's what I told you, 12. So 3x squared plus 2x plus 1 to the power 5 multiplied with, if you take that 2 out, you get 3x plus 1. That's the answer. Okay, so this is what we have to do. Now what I will do, so I will just write here because otherwise this part is so crowded. So now I see Michael Jackson here, MJ, but I don't have MJ here. What I will do the construction if you don't have that. And then this is related with base case number 1, right? So what I will do, I will create it. Minus 3x cubed plus 2x squared plus 1. Here we have that, right? So you're going to keep that. Plus 2x to the power 2 plus 1 minus 4 multiplied with the same thing in the denominator. So d minus 3x squared plus 2x squared plus 1. So please understand, these things are algebra, right? This can be humongous. So many terms, doesn't matter, right? Don't be scared. Just stick with your fundamentals and use it. Dx. Then if you have that, so this is to the power minus 4, right? So mj to the power minus 4. So it should be minus 4 mj, right? Mj would be minus 3x cubed plus 2x squared plus 1, right? So minus 1 is going to be minus 5 times. You can consider these things individually. Why? Because you have additions here, right? So it's going to be minus 6x. Here it should be 4x. It should be 0 there, right?
Sir,
Yeah, go ahead.
it's minus 3x to the power of 3.
Where? Oh, sorry. Yeah, so it's going to be 9, right? Right?
Yep.
Yeah, 9 squared. So now, is there any common thing you can take out? Yes, x, you can take out x, right? So I would say minus 4x. Then if I take x out, I will get here minus 9x plus 4 minus 9x plus 4, right? Then what I will do, this is minus 5, right? So I will put it in here, the denominator. That would be my answer. Any questions? So you get that question, right? I would say question number A. d dx sin x divided by, what was the other? What was the denominator?
3x squared.
Okay, 3x squared. So now how do you do this? This is a division, right? This is a division. First, you have to see that. Then I will do the division rule. 3x squared, square of it. Then I will put 3x squared here. Then derivative of the other, which is sin x, right? Derivative of the other, then minus sin x here, then d dx of 3x squared. So when you do that, here sin x, d dx of sin x is cos x. So 3x squared cos x. Okay. Here 3x squared, you can take this out. So it's going to be x squared. It's going to be 2x now. It's going to be 6x. So minus 6x sin x. The whole thing divided by, this is going to be 9x to the power 4. Right? So now you can see 6, 3, 9. You can do simplify. X squared, x, x3, x4, you can simplify. So I would say x cos x minus 2 sin x divided by 3x to the power 3. That should be the answer. Did you get that?
Yeah.
Okay.
Yeah.
Yeah. So that is the thing. And then what is the next question? Next question is 4e square root of x. 4e square root of x. 4e square root of x. So then I will discuss this later. Okay. So I need to first teach you the material. Okay. For the second base case, because I didn't discuss the second base case yet. Now, okay, let me see the other question. Yeah, this also you have to have the second base case. That's fine. So I hope so far so good. Clear? Okay. Any questions?
Oh, good, sir.
All good. Now I will show you something here. Okay. Can you see? Can you see here? Right. This is the question that we discussed before. We constructed it 2x plus 1 and we cancel it, right? See, you can see that. Here also, the same thing is repeated, right? Now, why this lesson is called chain rule? Who can tell me? This lesson I started, the name of the lesson is chain rule. Who can tell me why people are saying this is chain rule? This technique is chain rule. You understood the technique, right? Construction, looking at MJ. Those are my words, okay? Everybody is not going to teach you in this way. I help you to construct it using that MJ concept. Now, we learned a theory. We learned essentially a construction, right? So that's it. And the topic of that construction is chain rule. Now, can you tell me why people call this chain rule? Yeah, go ahead. The reason is, now you can see two blocks here, right? This red box and the black box, right? You can see. And, you know, they are separated by a multiplication, right? They're separated by a multiplication. Can you see that this block is connecting to this block via the denominator? See? Can you see? With these two. Connection is these two. Can you see?
Yeah.
Right? Now, if it is a chain, you know, like if you have pets, right? So you have sort of like chain, right? Chains are like this, right? This is one loop. The second loop is attached to this. The next loop is attached to this. The next loop is attached to this. Like that, right? This is how you make a chain, right? These are like metallic loops, right? Now, this loop is attached with this loop, this circle, with this small portion, right? This is the surface. Likewise, this loop, the red loop, red box, is attached to the black loop or the black box, right? By using the denominator, see? Same denominator, see? That is the attachment, right? See, that is the attachment. Here, can you see the attachment? See, this one is going to attach with this one, with this is the attachment. See, here in this example, see, look at this. This is the attachment. Same thing, right? Same thing. That is the attachment. if you see this one, see, this is the attachment. This is attached with these two similarity. Right? You understand what I'm saying? So now that was our pure construction. I taught you a logical construction. I taught you a logical construction so that we can do the math. But behind that math, we see a structure where two loops are connecting. Two loops are connecting with the denominator and the numerator of the other one. Right? So people call this chain rule in math. Why? Because due to this construction, due to this MJ construction, you have a chain type of behavior. If you consider this to be one loop and this to be another loop, these two loops are connected by using this guy and that guy, same thing, right? That's why people call this chain rule. It's a chain. You feel what I'm saying?
Yep.
Okay, you feel what I'm saying? Okay, good. I'll give you another example so that you will learn better. This is little advanced question. Try to tackle it. If I give you 3, 2x squared plus 1 plus, to the power 3 plus 2x squared, okay? Do it very carefully, okay? The whole thing to the power 3. Do it very carefully. See whether I can do that. Let's see. Okay. This is humongous, right? Okay, code paste. Yep. So I can see first, I see this 3. I'm explaining to you. I'm explaining to you with, hold on. Yeah. So I'm explaining this to you one by one, right? So one operation by operation. So I can see 3 here. So I know this is, the entire thing is mainly related with, okay, base case number 1. So now base case number 1, I know mj down, mj to the power n. Now this is my mj, right? This is my mj, this homologous thing. So I will construct it accordingly. So d, now be careful, 3, 2x squared plus 1, 3, 2x squared. Okay. That is my mj there. The mj in the numerator, that would be 3, 2x squared plus 1 to the power 3 plus 2x squared and 3. Done. Constructed it. So then chain rule. Now I am using the word chain rule. So this block is connected with the other block. So essentially I am going to remove the construction, right? So people use different words, but we'll keep the understanding. 3 plus 2x squared divide by dx. Okay. Now divide by dx. So now this block is all right. You can see this block is all right. Why? Because you can see mj to the power 3, all good. But what about this block? What about this block? Now that is what we are going to discuss now. Now that block, I can see this plus sign. Look at my thinking. I can see this plus sign. There is no power here. So I'm going to split it. This block, I'm going to split now. Okay. So I will do ddx. So this 3 I'm going to take out. 2x squared plus 1 to the power 3. Okay, I'm going to split it. Plus, I'm going to take 2 out. 2 ddx of x squared. Right? That I did. Hope it is okay with you. Now, if you think about this block, no problem. You can do that. See, base case number 1. Right? But if you look at this block, Again problematic. Again problematic. Why? Here you have mj, here you don't have mj. See? Mj to the power 3. Now what I will do, if you have that, we'll break it. To differentiate this, what do you do? Construct it. So 3 ddx of, sorry, not ddx, right? So I will do it directly, right? So that would be d 2x squared plus 1. Now I took mj there. So 2x squared plus 1 to the power 3 times, now I do the chain rule, I'm cancelling it, d 2x plus 2x squared plus 1 divided by dx. That's all about it. Now, if you look at this, now, if you look at this block, that block is all right. What about this block? This block also all right, right? Why? Because you can split it, right? So this also all right, right? So if I want to show you the details, this is nothing but you can write 2 dx x squared plus this, right? So this is going to be 0, right? So this one is not a big deal now. So this one is all right. See, we broke the problem. Now I will show you the chain rule. Okay, so see, I'm doing the question like as a series, see, as a continuation, see. So first step, second step, third step. Now chain rule, here I have used the construction, right? So this is my chain rule. Where else? Here I have used the chain rule, see. So in this question, chain rule, CR, chain rule, CR. So in this question, I have done chain rule 2 times. Before we have only 1 time, see. In this question, we have only 1 time chain rule. 1 time. Because here we could easily, simplify it. Okay. But here we constructed it. Once we constructed that, this part, we concentrated on this part. This part has this problem 3. Then sort of we break it down and then again use the chain rule to tackle that. Okay, so this is a chain rule after chain rule. So now in a chaining business, this is one loop, right? So here it's like one loop connected with another loop. Here, see, it's one loop here, right? It's one connection, one chain rule, one chain. Now here, how many connections there? 1 and 2. So it's like one loop is connected with this. Then there is another one, it is connected with this. That's the physical picture. See? There are 2 loops. This one goes with this chain rule. This one goes with this chain rule. So if you look at the structure, you see, it's like a chain. I'm connecting with this loop with that, with the chain rule. This loop with this, with the chain rule. You can see that clearly now. Now this question, I don't think you will ever get a question like this. No, I have never seen a question like this. But what we do now what we do is we are just understanding the material, right? So okay, so when we understand it, so right, so when we understand it, so we sort of we have to do like hard questions so that we understand that to the right depth, right? Any questions? Any questions? So now we know the structure. So we'll talk about the second base case. base case number 2. So in base case number 2, what we know is ddx of e to the power x is equal to e to the power x. Now what we have to emphasize here, if you have dmj, mj should be here on top. Then answer would be emj. Okay, so this is the criteria. Now if I have, same thing is used here, same chain rule is used here. If I have ddx of e 2x plus 1, how to do that? Now first of all, you will check which base case is related with. So related with base case number 2. But then once you decide your base case, you will go to your mj formulation. Then you will see where mj is situated at. So mj is situated at here, right? So denominator of BSD you have mj and e to the power. So in the exponent you have mj. Now this is your mj now, right? So this is your mj, but you don't have mj here to use that rule. What you do? You construct it. So look at this. de 2x plus 1. This is your mj. Then you will put your mj down. 2x plus 1. See? Now the criterion is satisfied. mj, 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 mj. So now this is the construction. We will cancel the construction. See? That is the chain rule. See? Construction, we are going to cancel it. So divided by dx. Now you will see here it's very straightforward, right? So this one is straightforward. That is the criteria, right? So this is going to be e. If you have mj, mj, this should be e to the power mj. So this is going to be e 2x plus 1, right? Times here, this is easy, right? This is nothing but ddx of 2 x plus ddx of 1, right? So this is going to be 0. This is going to be 2 here. So the answer would be 2 times e 2x plus 1. Okay. So that's the answer. So let me know if you have any question. So this is the full description. Okay. So this part related with base case 2. This part related with base case 1. Okay. Now what we will do, now you have mj here, but you don't have mj here, right? See, here you have 2x, here you have x. So it doesn't matter what you have here, you don't have the same thing there, right? So what you will do, 2x plus 1 to the power 5, it's like it's here, right? This is just multiplying. So now what we will do, we will use a chain rule. So you will construct 2x here, e to the power 2x here, and you cancel that 2x, d 2x dx. So that part is done. Plus, so this part is done, right? Plus e to the power 2x. This is the full description, okay? Now here you can see mj here, but you don't have that here. So this is just pure multiplication, right? So we'll put a bracket. So d 2x plus 1. Here you have 2x plus 1 to the power 5 times, you will cancel it, d 2x plus 1 divided by dx. Okay, so now you have that. Now what about this? This is so easy. So this is, you can take 2 out. So ddx of x would be 1. So answer is 2. This one also easy. So answer also 2 here, right? Because ddx of 1 is 0. You can take 2 out. ddx of x is 1. So just 2. Answer here is very easy. Why? Because this is base case number 1. mj is satisfied. mj. So you can say 5 mj 2x plus 1 to the power 4. Here again mj is satisfied. So the answer would be, if you have that, answer would be e to the power 2x. Right? So You know the base case number 2. DMJ, DEMJ is EMJ, right? So once you compile everything, you will get here 2 e to the power 2x, 2x plus 1 to the power 5, plus this plus sign. Then you have a to the power 2x. Here you have 2 this is multiplication, right? So everything is multiplied. So 2 times 5 is 10. Then you get e 2x. Here you get 2x plus 1 to the power 4. That's the answer. And if you want, you can further simplify. Okay, if you want, you can further simplify. That would be you can take 2 out, and e to the power 2x out, and 2x plus 1 to the power 4 out. If you do that, here you get 2x plus 1, right? So here you get, it's just 5, right? So if you further simplify it, it's 2x plus 1 plus 5, it's going to be 2x plus 6. So it's going to be 2e 2x. This is 2x plus 6, right? I'm going to take 2 out. This is going to be 4, right? So 2x plus 1 to the power 4. So here you got 2x plus 6, so it's going to be x plus 3. Okay, so that's how you do that question.